First speaker that I want to introduce to the stage is Angel. Hello, Angel.
Hi, how are you?
I'm good. How are you?
Good afternoon. Everything's well here.
That's good. It's not afternoon for you, right? It's morning for you.
Yeah, no, it's morning. I'm on the East Coast in the United States, right outside of Philadelphia in New Jersey. So yeah, it's a nice cold morning for us today. So.
Okay.
Yeah.
I checked out your information a bit, and what I immediately noticed is you used to work at Cape Canaveral.
Yeah.
That must be like a great and inspiring environment to work.
Yeah, so I was in the United States Air Force as a young man, and I got stationed at Cape Canaveral Air Force Station, and I was actually working on missions where we were actually launching human beings still, right? The space shuttle program. So yeah, it was really exciting. I started my career there pretty much in technology, right? So being surrounded by all those brilliant computer scientists and data people kind of inspired me to go into technology.
So how do you do that? It does not get better than that, right?
So it's just different. It has its good points and its bad points, right? There's a lot of really smart people who are willing to share a lot of information with you, but there's also the problem of being inside of a huge bureaucracy, right? A big organization. So depending on where you are in those environments, things can move quickly and there's a lot of innovation. And then there's also like, oh, wait, we have to think about safety and other things, right? So it's a double-edged sword, but definitely something to try and work in an environment like that for a couple of years to get to just basically get the experience. Some people stay forever. I enjoyed it, but yeah, it was just too big of a organization. So.
Okay, you're also a regular speaker and you're organizer of user groups and hackathons and stuff like that. Which ones?
Yeah, I was working in the federal government for a few years. While I was doing that, it's a really tricky situation to be in as a technologist because you can only engage in certain things because the image of being what do you say? The image of being biased in certain technologies. Right. So I would have to sit on boards. Anyway, long story short, yeah, I did a lot of organization of meetups locally here. So for folks who are like myself who couldn't really, in the jobs we were doing, we weren't really working with the latest technology. So you have to keep your skills sharp. I created a couple of meetups in my local area here in Philadelphia to kind of keep, my tools sharp outside of work. And also the hackathons were a great way to do that. But mainly I worked with high school and college students during those times. So yeah, I've been doing developer relations for a very long time, officially and unofficially. So yeah.
Okay. You're going to keep us sharp now with some information about how to optimize our pipelines for continuous integration, continuous deployment. Sure. So I would like to say, give it to us.
All right. Thank you so much. Hello to everyone. Thank you for attending this talk. Before I get started, I kind of put this talk together because of the conversations and experience that I've had with basically continuous integration, continuous delivery, and managing that stuff at scale. So this is kind of like the theme of the talk, and then I'm going to get into some specifics. All right, so first off, my name is Angel Rivera. I'm developer advocate for Circle CI. And as I mentioned earlier, I started my career off in the United States Air Force, United States Air Force Space Command. It was a really cool job. I got to meet a lot of interesting people, learn a lot of new things. But now today I work as a developer advocate, and the people, for those of you that don't know, what I do as a developer advocate for Circle CI is basically interact with developers such as yourselves, technology people. Pre-COVID-19, we were doing this right in person and at events such as sfday. But what I do today is basically, virtual conferences, which is just as good, or not just as good, but it's okay. And today I wanted to talk to you about some of the experiences I've had myself and in conversations with other people regarding pipelines, managing them at scale and being very performant as a development team or as an individual developer. So what I'm going to be kind of talking about are things regarding pipelines at scale, right? So we're developers, we're always managing things, and our projects usually start off really, really small, and then slowly but surely they start growing and growing, right? More lines of code, more services are added to the project, more infrastructure, right? And then on top of that, you have to automate all the things to make sure that you're producing the best software that you can, right? Generating the best releases so that hopefully you don't have any issues down the road with your deployments and your releases, right, while they're in production. So the thing I'm going to really focus in on, though, is regarding CI/CD, continuous integration, continuous deployment tooling, and some of the obstacles that I've encountered personally and others have as well in my conversations. So let's start with the word agility. We're developers, we're technology people. We're supposed to keep our products and our services moving, and innovating at a very fast pace, right? So our ops tempo, our development tempo is super, super high. And if you look at the word agility, right, let's take a look at the definition, which is basically the ability to move quickly and easily, right? And that's kind of where like the agile methodology kind of was born from, right? Software development was really, really cumbersome. Some of the processes were just, waterfall. Come on, that was really antiquated and blocking in certain aspects. But agility is great, but we're kind of in this new DevOps space, right, where we have to perform at a very, very high rate and keep a high software development cadence and velocity. So I kind of came up with this definition of my own, which I call CI/CD agility. And there's nothing new here, right? I just basically added a word to the definition of agility, but I define it as the ability to move continuously, quickly, and easily. And I think that makes sense, right? Because we're always kind of iterating within our processes. So yeah, kind of coined a new term there, CI/CD agility. You can use it if you like, but I just kind of want to set the tone for what I'm going to be talking about regarding, velocity, agility, and all the good things that make us super efficient. So these are the two topics I'm going to hone in on in this talk. The first thing I'm going to tackle is pipeline optimization, right? How can we basically create continuous CI/CD pipelines that are pretty optimized, right? That help us actually implement continuous integration and continuous deployments in a really efficient manner. And then I'm going to talk about what I call pipeline sprawl. If you don't understand what pipeline sprawl is, it's okay. I kind of made this word up. So I'll get deeper into it and you'll understand a little bit better what that is. So let's talk about pipeline optimization. The things I'm going to cover in this little bit of pipeline optimization is going to be resource classes, concurrent jobs, caching, and what I call selective job processing. So let's start with resource classes. Basically, what I'm saying here is a resource class is where we have to, when we're running our CI/CD pipelines, that code has to actually be executed on some runtime, right? On some compute node somewhere. And generally what the problem is that we face is we're running our CI/CD pipelines and jobs on inadequately sized compute nodes. And what I mean by that is, let's say, I have a build job and I'm going to build a Docker image. I've actually seen where customers are using, inadequately sized compute nodes, maybe like, 4 gig RAM, maybe 2 CPUs, right? And then they're wondering why their pipelines are not, speedy and completing at a quick pace. This definitely, when you have a under-resourced compute node running your pipeline jobs, it's definitely going to impact the build time, right? And what we're trying to do is, get those builds completed as quickly as possible so that we can get that feedback loop, right? That signal that our code is actually, been tested and built, and all the good things are happening, right? But generally what happens is when folks are running this stuff on inadequately sized compute nodes, obviously, right, things are much slower. And some of the fears that people have regarding, like, running things on more expensive resource classes is cost, right? They're afraid that they're going to get a bill for, I don't know, $100 more or $2,000 more, maybe even $100,000 more because they're using higher classed resources, right? Things that have much more horsepower, so to speak, right, for their builds. But I can tell you from experience that that's not the case. Those resources may cost you a little bit more, but in the grand scheme of things, right, when you're considering, time, people's time, sitting around waiting on builds, that gets cut down. Also, the builds themselves, get completed way faster, right, on faster hardware. So, consider that when you're factoring in costs, right, and don't right away go to the negative extreme of, oh wow, this is going to cost me a ton of money. In my experience, it's actually either even flush, the costs are just the same and don't really have an impact, or they cost like pennies more, right, per build, which is really, like I said, in the grand scheme of things, when you factor in the total cost of all those builds, including people's time, right? They're waiting, because I know tons of developers that sit around, push code up to their CI/CD platforms and then sit and wait for a green build, right, so that they can move on to the next task in their sprint. Again, keep an eye on your resource classes. Make sure that you have enough horsepower to actually run your builds in a manner that will hopefully get you completed in the shortest amount of time possible. The next thing I want to talk about in optimizing pipelines is running jobs concurrently, right? So this is when you have a couple of build jobs within your pipeline, and they can be run simultaneously, right? What happens here is folks start building these kind of artificial dependencies within their pipelines. And I've seen this quite a bit of times, right? So for example, let's say you have a job that does maybe a unit test, and another job that does a security scan, and one more job that packages up that application into a Docker image release, right? Those things can all be done at the same time. But some folks want to test first, then build a dependency, right? Another blocker to then, maybe build, security scan, right? The image. Or the code, and then they want to build the image. So, like, right, you're building a linear kind of blocking situation there, where in reality, do you really need to block all those things? No. I would say run all three at the same time. So, right, you're cutting down the time for your pipeline builds, which is really important. And again, right, avoid building those job dependencies. Obviously, there's going to be points where you need to build dependencies. For instance, if you have a step where you're, maybe going to deploy to a new system, maybe you're building a Kubernetes platform or Kubernetes cluster inside of your pipeline, you would then need to have a dependency, right, where deploying that application would have to be a blocker, right? So you need the cluster before you can deploy. That makes sense. But anywhere you can eliminate these, build dependencies, definitely look for that in your pipelines and make sure that they're running in parallel, right? But again, right, just you have to kind of look at the patterns and be logical about it, right? Like, does it make sense to run this sequentially, or does it make sense to build this dependency? So the next step I want to talk about is caching. This is kind of a controversial thing, but in general, there are some patterns that we can implement in caching that I'll share with you in a moment to help you, again, speed things up, right? Keep your pipelines running and as smoothly as possible. One thing I will say is we need to cache cautiously. What I've seen folks do is kind of leverage caching in very scary ways. And the reason I say that is, they think that, okay, I'm going to cache this, it's going to speed things up. The problem is, sometimes you have stale content or stale, data files inside your cache. On the other side of the coin, people are caching everything, right? So one of the things I will recommend is make sure that you're only caching the things that need to be updated, or I should say update only the things that need to be updated in your cache. So in general, right, once you, let's say, have an npm kind of a project or a node project, you have those dependencies cached. You can leverage the npm cache or the npm dependency manager to keep an eye on the dependencies that are or the versioning the dependencies, and then that package manager obviously gives you the ability to upgrade certain packages when you need to, and that's kind of what I'm saying here is, when you're caching, don't cache all the things, right? Meaning don't cache all of the dependencies, only cache the things that are absolutely required for your application, and then update those dependencies atomically, right? So you're not updating the whole cache every time, because that will slow your builds down dramatically and defeats the purpose of the cache, right? So let's talk about selective job processing. And there's two topics within that whole selective job processing. And what I mean by selective job processing is being able to kind of control and filter out the different segments in your pipeline. One of the things I see developers do, especially when they're building out jobs within their pipelines for testing, sometimes they're running inappropriate tests at inappropriate times. So if your application is in this segment of development process where it's just being developed, right? Things are just kind of being proven out. You're building maybe MVPs, maybe you're building, some proof of concepts, whatever. Do you really need to run comprehensive integration tests and comprehensive functional testing suites on this code when it really hasn't even been flushed out? I see a lot of folks kind of just run all of the test things that they have in their pipelines, and that's great that you're getting all that validation up front. I mean, it's important to have that, but at certain times in your pipeline, do you really need to be running those? And that's kind of what I'm talking about regarding test execution. Also, look at the tests themselves. A lot of times folks are just running tests because they've been there since the project started, right? I don't believe wholeheartedly in that approach. I believe that, we need to be looking at our tests often to make sure that, right, those tests are giving us the absolute best results and most valuable, most informed results that we need to ensure that our application is actually functioning per design. I see tons of people run the same test over and over and over, and they never fail. They're always green, and right. It depends on where you are in the segment of your pipelines, right? So if you're in that development stage, you can get away with unit tests, but make sure those unit tests are actually, giving you some feedback that's like really valuable and helpful to you, instead of just running them just to run it, right? I see that quite often. So conditional job execution is another layer here within the pipeline optimization. So what I mean by conditional job execution is what I talked about earlier about development segments, right? And then you have maybe a promotion to a staging or a QA type environment. And then finally, right, it hits production. So when you're looking at your pipelines, kind of figure out, at what point does it make sense to, promote these software release segments into the next level. What does it take to take from development and push it into production? What requirements are those? And then you kind of spec those out and then build your pipeline accordingly, right? So if your builds are passing a certain criteria, then they're ready to go. You can actually use the platforms to, create kind of filters and then automatically promote them into the next level, which means you're running more comprehensive testing on the next iteration of commits, right, for that project. So just, again, use some logic, right? Kind of set up a if this, then that kind of scenario within your pipelines. And finally, I want to talk about setting target build durations. So what I like to use is a 1-minute rule for every job segment inside of my pipelines. Now, you may be scratching your head and going, wow, that's impossible. And yes, it's true. It's not realistic. But what I'm trying to get at here is anytime I have a pipeline job that goes over a minute and, I see that, then I want to know why that's happening, right? Now, there's going to be situations, right, where, again, it's unrealistic. Like, let's say you're deploying, again, to maybe a cloud provider and you're building a Kubernetes cluster. That's going to take time, right? And depending on the cloud provider, it can take anywhere from 5 minutes to 25 minutes, right? Or 30 minutes. So, again, that's an unrealistic kind of 1 minute is an unrealistic expectation, but I'm just setting a goal for myself so that, right, I'm always constantly. So if I see anything busting my 60 seconds or 1 minute requirement, I'm, looking at why is it happening? And sometimes, it's going to be, 2 minutes, 3 minutes. That's okay. But as long as you know what's going on. And the reason for that is if you're constantly looking at these things and monitoring them, then you're going to more likely be, looking for more efficiencies, right? So you're going to try to squeeze a little bit more juice out of that lemon, right, so to speak. So set some target build durations. They can be my target goal is 60 seconds, 1 minute, but yours can be whatever makes sense for your team, right? Whatever makes sense for you to kind of keep a good cadence in your software development lifecycle and in your pipelines. The whole point is to keep things humming as quickly as possible, as smoothly as possible. Excuse me. So real quick recap. With pipeline optimizations, right? Resource classes, keep an eye on that. Make sure that you have adequately sized runtimes. Look at the costs, do some analysis on that. I'm pretty sure that the costs are kind of going to balance out for you. And then only use what you need, right? Like don't go overboard, but keep a nice set of resources there available to your runtimes or for your builds in your runtime. I like to use like a 20% rule. So plus 20% is good for me, right? So if I have something that I think is running, as expected, I would give it 20% more resources in case you come across, right, that situation where things just start slowing, because they're going to start slowing down eventually, but it gives you a little bit of buffer. So, concurrent jobs, right? Run things in parallel where you can and avoid these build job dependencies. They slow things down dramatically, trust me. So caching, right? Just update the things that need to be cached. Also, don't cache all the things, right? That's really important. And then selective job processing, right? Be aware of your test execution patterns, what's needed, what's not, what's test where comprehensively where you need to. Further down the pipeline is where I would suspect most of us will benefit from comprehensive testing. And then, of course, right, implement conditional job execution patterns, right? And also that the target build duration, right? Make sure you get a goal in your minds of how long each job in your pipeline should be. So now that I covered pipeline optimization, I know I'm kind of barreling through all this stuff. I hope I'm making sense. But with pipeline sprawl, it's basically, and I'll give you the definition, but it's basically where your pipelines are becoming more and more, and I'm talking in a technical sense, becoming more and more unwieldy or unmanageable. And some of this stuff happens because in current modern CI/CD platforms, everything's kind of run now, at least your pipelines are defined in what we call a pipeline config file, right? And those config files maintain basically all of the directives for your pipelines, right? It's almost basically like code, right? That tells your pipeline how to define itself, how to execute, and where to execute, right? But I want to say, with all of these CI/CD platforms that have, this configuration file, or this pipeline configuration file, the math is generally one-to-one. And what I mean by that is one code repository to one pipeline config file. Now, I understand that there are exceptions to this, right? So people use mono repos. People have different code repository strategies, and that's okay. But I'm just speaking to the general kind of usage that I've seen. And this is the math, right? A one-to-one, one code repository to one pipeline config. And I just wanted to kind of set the framework for the rest of this talk. So the other thing that is kind of apparent and obvious in these modern CI/CD platforms is that most of them are using a YAML-based kind of data structure, right, or syntax to define these pipelines. And as we all know, right, YAML is not a programming language. I don't know if you thought it was or you think it is, but it's not. It's basically a data structure, right? If you think of like JSON or what's the other one? But basically, let's talk about JSON. But basically, if you think of JSON, YAML is similar to that. Obviously, the syntax is cosmetically different, but for the most part, it's a declarative data structure that is actually being used in modern day solutions and innovations. So the cloud native kind of universe is using YAML, right? If you look at Kubernetes, it's the main kind of data structure used to define manifests and such. But basically, YAML is a data structure, and the problem with YAML is it's a data structure. It doesn't have any kind of operational kind of capabilities or functional capabilities. So the syntax can then become very redundant. And with that redundancy, the syntax will grow in complexity. So because, you don't have a reusability kind of component to YAML, I mean, there is a small one, but it's not very, it doesn't really help with what I'm talking about. It tends to grow in complexity and in volume, right? The syntax itself. And that becomes hard to navigate and manage, right? So when you have a lot of things that a human has to look at and maintain, it becomes very difficult, right? I'm sure we've all been there. So that also blends into what I call a configuration and then repo sprawl, right? So that's where you have large amounts of syntax in the configuration file, maybe thousands of lines of code. And then you also have a repo sprawl, which means, with the advent of microservices, we're adding a repo for every service, right? Unless you're running in a monorepo, which is not what we're talking about here. But you're starting to grow things, and that becomes difficult again to maintain because of all the volume. And now we're in a configuration / repo dilemma, right? Like, so how do we manage all this stuff? And how can we do it efficiently is the more important question. And a lot of folks have, kind of offered up, and I've had tons of discussions around this, maybe implementing some sort of GitOps pattern, and some smart people have come up with this whole GitOps operation and pattern and concept. But I can tell you that for this particular problem, pipeline sprawl, GitOps is not really a viable solution. It just doesn't lend itself to being helpful in this situation. Some of the things that happen with configuration in code is that we're hard coding, these commands because it's YAML. We're ending up with things like this, and this is kind of an example that I kind of ripped out of one of my configuration pipeline build files. If you look at that command line at the bottom, right, all we're doing is a simple AWS3 upload or copy into a bucket, right? And it's just a simple jar file. But imagine if you had to do that, if you had that line in 1,000 different configuration files. Let's just say you're just uploading one time in 1,000 different configuration files. Now I have to manage anything that changes because it's all hard coded, right? And it's a real problem. So what are the options, right? Like, what can we do to kind of alleviate some of that and get a process, an automated process in place so that we can actually, control and manage all of that code and all those pipeline repositories or pipeline configuration files that are very, very important to our operation. So as a developer, right, I kind of was thinking about the solution to this. And by the way, just thinking about problems like that, I just kind of went back and thought about the old days of object-oriented programming, right? And it's a similar problem, right, when you're trying to build code that's reusable. So what I did was I obviously, used the separations of concerns kind of practices and went ahead and identified all of my common patterns within my pipeline files, right? All the things that happen all the time, right? And then you just kind of say, all right, like let's take that S3 upload example. We're doing that, in 1,000 different files. So that means at least 1,000 different times. That is one good candidate as a pattern, right? An AWS S3 upload pattern that I took and I said, all right, I'm going to basically create an abstraction. Say, all right, that AWS S3 upload is kind of an object, right? The S3 upload, and I create an abstraction. And then I encapsulate all the functionality, meaning taking all of the variables and parameters that call needs, which is generally like the file and then where you want to put it. And you create these encapsulate all that and create these properties, so to speak, or parameters, and then you basically create a reusable module, right? And once you have that, then you're able to reuse a lot of that code. And what I'm talking about here is basically building a pipeline library, so to speak, right? And it's no different than having a script, basically a library of scripts that you use for whatever. Maybe you're an operations person, and you're provisioning machines. You have scripts to do that. Same thing is what I'm proposing here is creating kind of a script library to get all those things done, and then you'll be able to utilize those scripts, right? So if you take a look at that same example using a script library, and you look at the last command there, you can see that I'm basically building out a folder, right, with some scripts in it. This one happens to be named S3 upload.sh, and then I use variables to go ahead and inject the values for the parameters that it needs. And when you build out those pipeline libraries, that's just going to give you essentially managed a way to essentially manage that functionality, right? You're going to be able to make changes that impact all of your operations from one source, right? This is no different than kind of object-oriented programming concepts, right? We're building out these libraries so that we can essentially manage the functionality and then implement that very easily throughout. Again, when you're adopting a pipelines library kind of strategy, you're adding a lot of portability to your code, right? A lot of reusability, as well as minimizing the vendor lock-in, right? So if you've taken all of that functionality and encapsulated into these pipeline libraries, you can then take those same libraries and go from CI/CD vendor and platform to CI/CD vendor and platform, right? So because they're kind of independent of all of the vendor's proprietary requirements. So you're eliminating that vendor lock-in, or at least minimizing it, I should say. You're never going to eliminate vendor lock-in, but you're minimizing it. And then that gives you the ability to have a more dynamic CI/CD and DevOps kind of tooling, right? So some people like Jenkins, some people like Circle CI, some people like other CI/CD tools, right? And that's okay. You can actually bring all that together and leverage the same scripting libraries throughout each tooling, CI/CD tooling. So keep that in mind when you're building out things. I tend to always lean on this kind of thing first, right? So I hate vendor lock-in. So I definitely try to minimize that impact on my technology and my solutions, because eventually, right, we're in technology. Things will change. There'll be more innovative, better platform and tooling that becomes available to us, right? And we need to be able to take what we have and transport that over as easily and quickly as possible. And it's actually, the actual word is to be as painless as possible for us, right? Because that's how you get the value. At Circle CI, we actually built this kind of parameterized functionality, and we call that orbs. So what we've done is we outfitted the platform to handle parameterized YAML. So you can build that reusability within your YAML files, and our platform knows how to, process that and then implement it and execute it in your pipelines. We also have, for that centrally managed kind of encapsulation and effect, we have created what we call an orbs registry. So it's similar to like NPM or Docker Hub, right? You can build out this parameterized YAML and then share it with other people, share it with the community, or just keep it in the registry for your own uses. And you can also again, keep maintenance in one-stop shop, right? So if you add some new functionality or change something, all you're really doing is changing the code and then creating a new version of that same orb. So again, with pipeline sprawl, it's a really difficult problem to solve, but hopefully I gave you some advice on how to do that. And I'll just do a quick recap on the things I talked about regarding pipeline sprawl. The first thing you should do is identifying the common patterns in your pipelines, encapsulate those patterns into a useful functionality, and then create parameterized scripts, and then you can use those scripts to execute and centrally manage that code. And then finally, right, it helps with adding a lot of portability and reusability to your code and to your pipeline jobs, and also minimizes that vendor lock-in. And that's about it for me today. I want to thank all of you for listening to me ramble on about Cicd Agility and pipeline sprawl and all those things. I like to have conversations, but I'll also take questions. So I'll be here to answer and just converse. Thank you.
Thank you very much, Angel. That was quite interesting. If anyone has any questions, feel free to share them in the stage chat. And I see a question come in, actually. Let's have a look. We work hard to minimize vendor lock-in on infrastructure, still relying on S3 buckets and other vendor-oriented assumptions. Is that important to avoid vendor lock-in? Are we sure? Should we carefully choose the vendor, the technology, the third-party library, and so on? Instead, and stop fighting against lock-in, or just focusing on the business?
Yeah, so yes, all of those things are true, but think about this, and this has happened to me many times in my career, where I've had multiple jobs. Like I said, I was working in big organizations like the Air Force and NASA, federal governments, other enterprises, and also startups, right? And the one thing I see that's common throughout all of those experiences in my 26 plus years is that eventually the technologies you're using today will not be the technologies you should be using in 3 to 5 years. You see this with banks, right? They're still running COBOL. Why are we doing that, right? Why is that happening? I know it's expensive, and that's my point. Is you have to look at, like, at least I do. I look at how am I going to get my data out of these solutions in 3 to 5 years, right? And if the vendor does not have a good explanation on this, then I'm not going to select them as my the solution of choice. We need to rethinking about our data, because I have this, and it may be controversial, but I have this belief that we focus way too much on our applications and not enough on our data. We're treating that data as second-class citizens. And if you really look at what's happening, the data is the gold, right? Like without that, these big companies that we use, social media companies, whatever, even financial systems, the data is what gets them brings the value to their businesses. So while yes, we need stability, we need to be capable in the technologies, we also need to be thinking about the future, right? I'm not trying to future-proof anything, but I just like to kind of focus in on the data, which is the really important part, right? How am I going to get this data out of this system and transition it into this newer system that I'm going to be using in 5 years, right? That's where I kind of have a problem with vendor lock-in. And by the way, I've been there. Like I said, I worked in big organizations, and when we wanted to take data from maybe 20 years of data, and let's say a government institution, 20 years of data, and move it in just to like a new database, a relational database from a flat 80 cart system, it costs millions, tens of millions of dollars to do that. Whereas, we could have, had a plan to kind of transition over eventually, because we knew that those older systems were no longer going to be supported by the vendor. And that's part of the problem, right? So it's more, my point is, it's more expensive to maintain those old ass systems without having a plan to, migrate over to some new technology.
Right. You were talking earlier about identifying patterns. Can you share some insight on how you identify those patterns?
Yeah. So, honestly, what I'm an automator. So what I did was a bunch of Perl scripts to find, and to comb through a bunch of files and look for the commands. And then I can do a count of how many commands occur in these files, right? So I'm talking strictly pipeline. And then that gives me a nice graph of what is like the most common patterns, right? From most used all the way down to least used. And then I can basically have a list to go through and then start encapsulating that functionality, if that makes sense. That's one of the easier ways. Yeah.
Yeah. And then how can developers establish a better adoption of, DevOps principles?
Yeah, that's a good question. And that has a different answer for every team, every individual. But I believe that the first place you need to really start is tackling if you want to implement or adopt DevOps, is definitely identify, almost again, looking for like a pattern, but identifying what your current culture is on your teams, right? How are people operating? How are people interacting? CI/CD, DevOps, all that stuff is all conceptual. If you think about it, right? These are all kind of cultural things. If you look at continuous integration, what are you doing there? You're basically adopting a way to communicate and collaborate with your teammates around code, right? Basically, that's what we're doing. We're not trying, take the platforms and stuff out of it. If you look at the principles of continuous integration, we're literally trying to, understand how our coworkers, our teammates are building software and the changes that they're making, and learning about those changes as quickly as possible, right? It's all about feedback loops. And that's where you need to kind of start is, what kind of team do I have? How are we operating? How are we collaborating around code? I see this all the time where folks just start, trying to implement, maybe they're running Jenkins and they use Circle CI to just, change it out and think that, wow, this is going to make my team faster. In reality, no, you're going to have the same problems, just in a different tool. Right? So again, it's a cultural thing. You need to just look at how your team is operating. And if you want to lead that charge, that's great. Find people who are similar to you, maybe are a little bit passionate about the same things, especially around software development, and start maybe forming some collaboration communication skills amongst maybe the 2 or 3 of you, however many people you have. And what happens is you'll start seeing that other people are going to be like, how are you building this stuff so fast? And how is it like, if you have like these, what they call them, code reviews, right? I've seen it where a couple individuals get together and they start working really tightly together. And in the code reviews, right, everything's pretty tight. Everything's done quickly. And they're kind of looking at each other's work. They're actually coordinating outside of the tools. They're coordinating when someone's going to start work. So if let's say you and I have a task that kind of overlaps, we're going to touch the same code base. Before you even start coding, you should be having that conversation like, hey, what makes sense? Should I do my changes first or you, right? You work that all out before, And again, right, you're communicating, collaborating around this task, and then you're going to be way more efficient. So while you're, developing your pieces, I can go and develop my own, or sorry, work on some other things. And then when your stuff's done, I can, jump on it and make my changes, right? Again, you're avoiding that merge conflict. And I think that's a good indicator for me, at least. I use, like, if I'm working with someone else and we're overlapping, I'm like, all right, how am I going to prevent a merge conflict, right? Like, and it's very easy. Just say, hey, who's going to do this first? And then we'll move on, right? So that's my advice in that situation is, get your culture, understand your culture, and then figure out ways to make those changes. I would recommend also starting with small, inconsequential things, because then you can kind of prove things without really, damaging on a wide scale.
Okay. Thank you very much, Angel, for being with us and sharing all this knowledge.
Well, thank you. And I really appreciate being here. And I hope everyone stays safe, right? Mask up, do all those things. And hopefully we'll see each other next year in person. Yeah. Thank you so much.